How sonar works. We are actually adapting from nature behavior like animals such as dolphins and killer whales. And we are developing through technology using software and hardware. Normally, Transducer is the device that we use for sonar application. Transducer is a device that converts variation in physical quantity such as pressure or sound into an electrical signal or vice versa. The transducer transmits and receives back the signal it made. A sound created from transducer is called as ping for every pulse that it has produced. So currently we have two types of sonar system, which are active and passive sonar. For active sonar, the transducer emits pulses of sounds and listen for the echoes. Active sonar use a sound transmitter and a receiver. Usually, the system will employ ultrasonic frequency. For normal use, it is from 12 up to hundreds of kilohertz, or sometimes thousands of kilohertz. For example, like the system used for depth measurement, detecting features, and locate things underwater. And sometimes, the lower frequency system is used to penetrate deeper into the Earth's crust beneath the oceans, with frequency of 3.5 kHz and sometimes lower. They will use this if they wanted to see accumulated layers or sub-bottom layers of sediment to study Earth. Like seismic applications, they will use the bubble explosion or EGAN. Some energy is reflected directly even at a distances, but sometimes, based on the nature of the object or sediment, the energy is also refracted, and the receiver needs to be placed at greater distance to monitor the detection. As the energy is quite low, it can vibrate longer and travel far. And another terms used for transducer system are monostatic and bistatic. When the transmitter and receiver are at one place in the system, it is called monostatic. While the system with transmitter and receiver placed at a different location, it is called as bistatic. As the concept of instrument use is utilizing sound and echo, few sonar are also called as echo sounder. For example, single beam echo sounder (SBES) and multi-beam echo sounder (MBES). There are also others like acoustic ground discrimination system (AGDS) and of course the side scan sonar. Passive sonar. A good example for passive sonar is hydrophone. For passive sonar, it only consists of a receiver, which is essentially used to listen for the sound made by others. It is sometimes stowed behind vessels or deep in a static mode for data acquisitions. This is some examples for passive sonar detection. To measure the distance or depth, sonar will just use the formula of speed. We will send an ultrasound and then we record back the time for the first echo detected. The speed formula, which is V, is equal to the distance over time, d over t. However, the sound here has travel goes and back. It means it travel through two distance. The formula should be V equal to 2d over t. To calculate the distance, we have to do some algebraic to the equation and it will become d equal to vt over 2. Let's do one example. As we know earlier, the speed of sound in seawater environment is about 1500 meters per second. Now, the total time taken for a detection from ship to the sea bottom is about 2.4 seconds. Using the formula d equal to vt over 2, 1500 meters per second times 2.4 seconds. As the seconds unit can be cancelled out, then it will be left only on for the meter units, and then divided by 2. The depth under the ship is determined by 1800 meters or 1.8 kilometer in depth. To get familiar with the calculations and formula, you can try to do these examples.